Factorising our algebra. Basic idea, often forgot it, but the first thing you always look for is just simply a common factor. Always look for your common factor first. Then the number of terms the expression has gives you a clue on how to solve it. If it only has two terms, not a heck of a lot of things that could be happening. Hey, was it a difference of two squares? Maybe it's that situation. Could be some difference of two cubes or something like that, or even higher powers. Three terms, now the sort of thing I'm looking for is, hey, is it a quadratic trinomial? What type of trinomial is it? It's got three terms, trinomial, but what type is it? Is it a quadratic? Four terms. Maybe grouping in pairs could be an idea. Look at it in two groups of two. Those are the sorts of things we're thinking about when we factorise. So first of all, just an example of common factor here, but to highlight, all you're doing when you're factorising is simply dividing. That's all it is. You're just dividing. So if I see ax plus bx, I'm dividing. Well, x is in both, I'll divide by x. Goes out the front, a plus b. 5x squared minus 10x. The trick here, of course, is to get all of the common factors. Sometimes we just pull the x out, or we just pull the 5 out. Now, everything that can be divided, we do it. So we're going to pull out 5x. Four terms. Okay, so yes, grouping in pairs. Which pair do I pick? Well, I've got to pick things that do have a common factor or something like that. I can play with those pairs. So what did I do? I pulled out the x of the first one, left with m minus n, which then meant for the second one, instead of dividing by y, I had to divide by negative y. Because I need what's inside the grouping symbol to be the same. If I pulled out the y, they wouldn't be the same. I've got to pull that out. Now I can complete the factorisation. I divide them both by n minus n, leaving me with x minus y. Okay, difference of two squares. We see that. It's just the expansion in reverse. By the way, which is more correct? A minus b, a plus b, or a plus b, a minus b? Who, when they're doing that, would write down, like I have here, a minus b, a plus b? Who would go that way? Who would go a plus b, a minus b? They're both correct, by the way. You can't get this one wrong. Okay, it is interesting. But actually, and I'll explain why, I don't know if it's in this one or when we're looking at cubics, but I'll explain why we put the minus first. You don't have to. So 16x squared minus 1, I would write it as 4x minus 1, 4x plus 1. But of course, you can multiply in any order, so it doesn't matter. 3y squared minus 75, hang on, they're not squares, but always pull out the common factor first. You pull out the common factor, you've then got the difference of two squares. There's our answer. Oh, here's grouping in pairs, but it's not a common factor that I'm going to pull out of the second one. That one I can do by difference of two squares, but it still works because I pull the 5 out, and in the second one when I group when I do the difference of two squares, I have that common factor now of x minus y. So I can do the division and I can factorise it. The quadratic trinomial, which we can think of in two ways. If it's monic, thank you. Monic's so much easier, because how do we do it? If you do it in reverse, expand that out, we end up with this. And this is why we say, oh, what multiplies together to give this number, what adds together to give this number? It comes from the expansion. We're just going out, we're putting it back. So if I see x squared plus 9x plus 18, I'm saying to myself, what multiplies together to give 18, adds together to give 9, 6 and 3, isn't it? So we get 6 and 3, it must have come from that. This one here, okay, but I notice it adds together to give a negative number. Therefore, I must be dealing with negatives if I'm multiplying to get a positive number. So we get t minus 3, t minus 1. Again, don't worry about the algebra. Look at the coefficients. That's what's important here. Technically, what we're saying is what multiplies together to give 4y squared and what multiplies together to give negative 5y. But again, the algebra is not that important here. It's the numbers. What multiplies together to give 4, adds together to give negative 5. And I just remember, oh, actually they're y's, so it's x minus y. X minus 4y. But if it's not a monic, there's different ways of doing it. You've seen the cross method, things like that. I like splitting the middle because it keeps me thinking the same way. So when I see something like this, it's still this idea of what multiplies together, what adds together with a little bit of a difference. We multiply the constant by the coefficients of the x squared. So I'll say what multiplies to give not negative 7, what multiplies together to give negative 21. And then what adds together to give 4. And then we physically split the middle term. into those two numbers. And you end up with a grouping in pairs question. So the first one I can pull out a common factor of 3x, the second one's 7. Oh, x minus 1's in both of those. There's the answer. So I like it because it keeps that same idea of what multiplies together to give, what adds together to give. It's the same idea. So this one here, I'd say, hey, what multiplies together to give negative 24 adds together to give negative 5. Now this is interesting because it adds to give a negative number, but it also multiplies to give a negative number. So I know the bigger number has to be the negative one, because when I add them together it's going to be negative. So I'm still looking for two numbers, but the bigger one has got to be well, when I say bigger in magnitude. Here I end up with negative 8 and positive 3. Pull out my common factors. Bingo, there's my answer. Okay.